This is Pre-Calc section 12.1 part 2. We are continuing our work on sequences. We are going to get to sums in a minute, but we need to look at one more recursively defined sequence where we're asked to find the first 5 terms. In the previous video, the way I did the recursively defined sequence terms was to think about a sub n minus 1 to be the previous term. But now we've also got this a sub n minus 2, which I think would be complicated if we think about it being the one in front of the previous term. So we're going to go back and do this just very strictly with the arithmetic. So we know a sub 1, we know a sub 2. That means we're getting ready to find a sub 3. So to find a sub 3, that means we're going to put a 3 here, a sub 3, put a 3 here, put a 3 here, and do a little simplifying. So a sub 3 would be a sub 2 times 3 minus 2 is 1 times a sub 1. So look back here, a sub 2 is 3, a sub 1 is negative 1, 3 times negative 1 is negative 3. Let's erase these. Now to find a sub 4 means I'm putting a 4 for that n, and that n, which is a sub 4 minus 1 is a sub 3, 4 minus 2 is 2. So we're doing the product of a sub 3 times a sub 2. A sub 3 we just found right here is negative 3. A sub 2 is 3. Negative 3 times 3 is negative 9. To find a sub 5, I will plug 5 in here once I do this erasing. Put 5 here, here, and here, which gives me 5 minus 1 is 4, a sub 4, times a sub 3. A sub 4 was negative 9, a sub 3 was negative 3, which gives me 27. So it says find the first 5 terms. We already had 2 of them, so it's negative 1, 3. A sub 3 we found to be negative 3, a sub 4 was negative 9, and a sub 5 is 27. So that's what I would suggest you do if you have an a sub n minus 1, but you also have an a sub n minus 2 involved. Now let's get into sums. This symbol right here, that's the Greek letter sigma, is telling you to find the sum or add up the terms. Now, to understand these things, this letter K right here is called the index of summation. It tells you where to start the sum and where to end it. This is your starting, this is where to end it. The value for which K begins is listed below, while the upper symbol tells you the final sum. Now, the index variable can be letters other than K, but you have to have agreement within the formula. What that means is if this is K equals something here, this letter right here has to be K. You could not have one that said for K equals 1 to 6 and let this be x squared in here. That would make no sense. We've got to have the same variable. That's what I mean by agreement. Now, one of the things you're going to be asked to do is just to write out the sum. Didn't say find the sum, write out the sum. That means plug 1 in for that K. This would be 1 over 1. Plus, plug 2 in for that K. 1 over 2. Plus, and the reason we're putting a plus in between is that we're asked to write out the sum, which indicates addition. Put 3 in for that K. And we're going to keep doing that all the way out to putting n in for that K, which gives us 1 over n. Because we have a variable here at the end, we cannot get an arithmetic sum. We were just asked to write out the sum, and that's it right there. Same thing over here. We're going to put 1 in for K, so that would be 1 factorial, plus put 2 in, 2 factorial, plus put 3 in, 3 factorial, etc., and we keep going until we would reach n. So those are just asking you to write out, really to show what it looks like when you plug in 1, plug in 2, plug in 3, and just want to say this, if this had been, let's say, K equals 2 to 6, and that's okay, it doesn't have to have an n up there, and it doesn't have to start with 1. Put 2 in here, 2 squared is 4. Put 3 in here, 3 squared is 9. Put 4 in, 4 squared is 16. Put 5 in, 5 squared is 25. And put 6 in, 6 squared is 36. And we stop right there because it's telling us find the sum for K equals 2, meaning beginning at 2, and going up to 6 is when you quit. Now this right here would be writing out the sum. If it said find the sum, we would actually have to add this up. You can plug it in the calculator. You can do it by hand. This is 13, 29, 54. This is going to be 90 for my sum of that one, which is what these next two problems ask. Find the sum of the sequence. Now, MATLAB just says find the sum, but the only way you're going to find this sum is to actually plug it in and do the arithmetic. So it says k equals 1. We're starting with 1. 2 to the first is 2, plus 1 is 3. Plus, put 2 in here. 2 squared is 4, plus 1 is 5. Put 3 in. 2 to the third is 8, plus 1 is 9. Put 4 in here. 2 to the fourth is 16, plus 1 is 17. Put 5 in here. 2 to the fifth is 32, plus 1 is 33. And 2 to the sixth is 64, plus 1 is 65. And we will add that up. And we stop at 6 because it tells me to stop at 6. Add all this up, and you will get 132. One more example with this same idea. We're starting for k equals 1 to 5. Put 1 in for that k. 6 times 1 is 6, plus 2 is 8. Put 2 in here. 6 times 2 is 12, plus 2 is 14. Put 3 in here. 6 times 3 is 18, plus 2 is 20. Put 4. 6 times 4 is 24, plus 2 is 26. And put 5 in there, and that's the last number you're going to put in there because that's the top number. 6 times 5 is 30, plus 2 is 32. Add all that up, and you will get 100. Last problem here is asking us to go backwards. It says express the sum using summation notation. If you look back at this answer here, we had it in summation notation and we had to write it out. So this is someone has already written it out and we have to figure out what the summation notation is. So start with the summation here. You have to figure out where you're going to start and where you're going to end. And of course, use whatever letter you want. I'm just going to continue with K because that's what we had used in the rest of the video. To figure out what this formula is, you realize it's a fraction, so I'll put a fraction line. And this is a sub 1 right here. It's the first term, it's a sub 1. If that's a sub 1, that means we were using k equal to 1 to get this 2/3. Well, what did we do to 1 to make it become a 2? Looks like we probably added 1. So k plus 1 is what looks like might work on the top. And I say might because I got to check it out with these other fractions. I could be wrong. On the bottom, for k equal to 1, what did we do to the 1 to make it become a 3? Well, we added 2. So it's looking like k plus 1 over k plus 2. Only way to know for sure is to check this out. This is a sub 2, which means k was 2. So does that give me 3/4 if I plug 2 in here and here? Yeah, it does. 2 plus 1 is 3. 2 plus 2 is 4. Check it for this. This is k sub 3. I mean, this is k equal to 3. So 3 plus 1 is 4. 3 plus 2 is 5. So that's looking good. The only thing I have to figure out is where to stop this because this has got dot, dot, dot in between. We ended up with 14/15. Well, if our formula is adding 1 to get the top number and adding 2 to get the bottom number, what did we add to 1 to get 14? Would have to be 13. What did we add to 2 to get 15? It would have to be 13. And that gives me my top number being 13, and this was k equals 1. I forgot to write the 1. That's not the only place. I could have started at k equals 2 if I wanted to, which would have changed this formula. I just think it's most of the time easier if you just start letting k equal 1.